Um, Imagine you are standing on the western edge of the Iberian Peninsula. You have the wind in your face, and you're just looking out over the vast, churning expanse of the North Atlantic Ocean.
Just endless water in every direction.
Exactly. From where you're standing, the water stretches out to the horizon unbroken. It just looks like endless ocean. But if you were to travel exactly 1,000 kilometers straight out into that water,
Which is a massive distance.
it really is, and then dive kilometers down into the pitch black, freezing depth, you would find something absolutely staggering. There is a colossal, unexplainable structure lurking at the very bottom of the sea.
We're talking about a massive underwater depression.
Yeah, a colossal relief carved right into the seabed. And for decades, its very existence has been this profound mystery to the scientific community. So welcome to today's deep dive.
Glad to be here.
Our mission today is to finally uncover the geological origins of this massive underwater enigma. To do this, we're looking at a really fascinating breakdown from a KULT Patreon post.
Right, which details a major breakthrough study.
Yeah. The research was led by the Geomar Helmholtz Center for Ocean Research, Kiel, and it was published by the American Geophysical Union in the journal Geochemistry, Geophysics, Geosystems.
It is a heavy-hitting, rigorous piece of science.
It really is. It finally gives us the answers to a geographic anomaly that has just completely defied explanation. Okay, let's unpack this, because we are dealing with a cold case that has baffled marine geologists for a very long time.
Well, when we talk about a discovery of this magnitude, we have to realize that this isn't just a story about, some rocks or a random ocean trench.
Right.
It is fundamentally a story about the invisible, immense forces churning deep within the Earth. Forces that operate on a timescale and a physical scale that completely dwarfs human history.
It's hard to even wrap your head around.
It is. We tend to look at the surface of our world, the continents we live on, the mountains we hike, and they feel incredibly permanent.
Right.
Solid.
Yeah, of course.
But the reality is that the surface of our planet is being constantly shaped, torn apart, and remade by engines operating hundreds of miles beneath our feet. This deep dive is going to highlight just how dynamic the Earth's crust actually is.
It is wild to think about how much of our own planet remains completely uncharted. We are so quick to look up at the stars and think of deep space as the ultimate frontier.
Oh, absolutely.
But the sheer scale of the ocean and the secrets hiding under billions of gallons of water right here on Earth are just as mind-blowing.
Completely agree.
So we're going to take our time today marveling at that scale. Let's start by visualizing the anatomy of this structure. It's officially known as the King's Trough Complex.
Just the name alone sounds imposing.
It really does.
Yeah.
And the dimensions absolutely back that up. According to the research, this structure extends for an astonishing 500 kilometers across the ocean floor.
500 kilometers is a massive scar on the face of the planet. I mean, if you were to drive that distance at highway speeds, you'd be in the car for 5 or 6 hours.
Just driving along a trench.
Exactly. And this isn't just a single, simple ditch. The research notes that the King's Trough Complex is comprised of a vast network of parallel trenches and broad ocean basins.
It's highly complex.
Very rugged, very dramatic topography, and entirely submerged under miles of water, sitting in complete darkness.
And the data points us to a specific feature at the eastern end of this complex called Peak Deep.
Right, Peak Deep.
Peak Deep isn't just another trench. The study highlights that it is considered one of the absolute deepest points in the entire Atlantic Ocean.
Which is saying something.
Definitely. And because of that extreme depth and the highly unusual rugged structure surrounding it, this specific area has become a crucial site for marine geology. Scientists have been looking at Peak Deep and the entire 500-kilometer King's Trough complex for years, just trying to figure out how it got there.
Because studying geology on land is one thing.
Right, like if you want to know how the Grand Canyon formed, you can walk right up to the edge, hike down, look at the layers of rock, and clearly see the Colorado River doing its work.
You can literally watch the water eroding the stone.
Exactly. But studying something 1,000 kilometers offshore and kilometers deep is an entirely different game. You are relying on sonar, bathymetry, and deep-sea probes just to get a blurry picture of the seabed.
And that Grand Canyon analogy is the perfect starting point for the mystery.
How so?
Well, we know how canyons on land form. Relentless, river water eroding rock over millions of years. But down at the bottom of the Atlantic Ocean, the research explicitly points out that there are absolutely no currents capable of eroding solid rock on a 500-kilometer scale.
Because the water down there is heavy and cold, right?
Exactly, it's dense. but it just doesn't move with the kind of localized, violent velocity needed to carve out broad ocean basins and parallel trenches. The mechanics of water erosion simply do not apply in this environment.
Right, the water isn't cutting through the rock like a saw. So if the water didn't carve it from above, we have a massive gap in our understanding. What forces could possibly carve a 500-kilometer trench in the middle of the ocean?
What's fascinating here is exactly that elimination process.
Ruling things out.
Yes, when you look at a structure that massive and you completely rule out surface level causes like water erosion, you're forced to change your entire perspective. You have to stop looking down from the top of the ocean and start looking up from the center of the Earth.
Oh, that's a great way to put it.
The lack of water erosion guides us to the realization that the seabed in the King's Trough complex wasn't carved or worn away from above at all. Instead, it was violently ripped apart from below by the planet's own internal forces.
Which points directly to the tectonic hypothesis.
Precisely. It's the primary mechanism shaping this underwater landscape. The seabed is simply responding to the immense pressure of the planet's internal dynamics.
Since we know the surface water didn't do this, we have to look deeper into the Earth and much further back in time. The data in the study transports us back to a period between 37 and 24 million years ago.
That is the critical window for the King's Trough.
So what was happening back then?
During that specific window of time, the geography of the world was actively shifting, a massive tectonic plate boundary. The literal seams separating the European plate and the African plate crossed through this exact region of the North Atlantic.
So you have to picture a continental tug-of-war happening in extreme slow motion.
Slow motion, but with unimaginable force.
The European plate and the African plate interacting right where this massive trench is today. When two colossal plates like that are pulling against each other, they don't just glide smoothly.
No, it's a violent grinding process.
The data shows us that over millions of years, these immense stresses literally fractured the oceanic crust. And it fractured specifically from east to west.
Tearing it open.
Yeah. As the crust cracked and pulled apart, it caused these massive depressions, the parallel trenches and the broad basins of the King's Trough, to gradually open up. The crust was quite literally tearing open under the tension.
Think about the physics of pulling a thick, rigid material from opposite sides. The tension builds and builds until the structural integrity fails.
It just gives that.
Right. The tearing of the oceanic crust from east to west is the physical manifestation of that failure. The plates pulled and the rock gave way, creating this massive void that we now call the King's Trough.
And this wasn't just a random guess by the scientists either. The research puts hard data behind this. I want to share a direct quote from the lead author of the study, Antje Dirkevelden, because she perfectly captures the significance of pinpointing this timeline.
She led the team at Jumar, right?
Yes, exactly. She states, quote, "Researchers have long suspected that tectonic processes played a central role in the formation of the King's Trough. But the crucial part of her statement is this." She adds, "Our results explain for the first time why this structure developed in precisely this location."
That is the key right there.
So what does this all mean?
It means that a decades-old geological cold case has finally been solved. For a long time, researchers had a strong hunch that tectonic forces were to blame for the King's Trough.
But a hunch isn't scientific proof.
Exactly. And a general theory about tectonic plates doesn't answer the specific why here aspect. Why didn't the crust tear 50 miles to the north or 100 miles to the south?
Right, why that exact spot?
By pinpointing the exact ancient boundary between the European and African plates from 37 to 24 million years ago, this discovery provides incredibly robust evidence for the overall tectonic evolution of the Atlantic Ocean.
It gives us a confirmed, fixed data point.
Yes. It helps map out exactly how the tectonic plates of our planet have migrated and deformed. It validates the theories about deep mantle processes influencing the formation of one of the largest submarine depressions near Europe. We aren't just guessing anymore, we have the receipts.
Here's where it gets really interesting.
Yeah.
If it was just the tectonic plates pulling apart, we might expect to see massive 500-kilometer troughs everywhere. Two plates meet and separate.
But we don't.
Exactly. We don't see features like the King's Trough at every divergent boundary. There had to be a hidden catalyst that made this specific spot so susceptible to tearing. And the study reveals exactly what that catalyst was.
The mantle plume.
Yes. The data points to a mantle plume, which the sources also refer to, incredibly poetically, as a mantle quill. I've heard the term mantle plume before in relation to volcanoes, But in this specific deep-sea scenario, I'm trying to picture what that actually does to the rock down there.
A mantle plume, or mantle quill, is a highly focused, extremely powerful column of incredibly hot material that rises directly from the Earth's deep interior, well beneath the outer crust.
Like a pillar of fire.
You can visualize it as a concentrated pillar of intense geothermal heat pushing up against the bottom of the oceanic crust. It is a localized hotspot of extreme thermal energy.
And the timeline the researchers discovered regarding this mantle plume is the real plot twist in the study. They found that the preheating phase happened before the European and African plate boundary ever arrived at that specific spot.
The timing is everything.
It really is. The data indicates that the oceanic crust at this location was already thickened, and it was already subjected to massive extreme temperatures from this mantle plume long before the tectonic tug-of-war even began.
That sequencing is the key to the entire mystery. The crust was preconditioned. Co-author Jörg Guildmacher provided a vital insight into why this preheating matters so much to the structural integrity of the rock.
What did he say?
He noted in the study that this thickened and heated crust may have made the region mechanically weaker.
That makes perfect sense when you think about the physics of everyday materials. It makes me think of trying to break a piece of heavy-duty plastic or a thick sheet of metal. If you just grab both ends and pull, nothing happens.
Right, it's far too rigid.
But if you take a blowtorch, which acts like our mantle plume in this scenario, and hold it directly under the center of that material for a while, the heat softens it.
It fundamentally changes the structure.
Yeah. The material might actually bulge and look thicker at first, but that intense concentrated heat weakens the molecular bonds. Then, once it's weakened by the blowtorch, if you start pulling from both sides, just like the European and African plates pulling apart, it yields and tears perfectly in that exact weakened spot.
The mantle plume acted as the geological blowtorch. It weakened the crust precisely at the location where the King's Trough would eventually form.
So it was just waiting to snap.
Exactly. When the massive stresses of the plate boundary arrived between 37 and 24 million years ago, the crust in that specific region was already thoroughly compromised. It tore east to west precisely because the deep mantle processes had primed the area.
The interaction between the mantle plume's extreme heat and the mechanical stress of the plate dynamics created the perfect geological storm.
The rock didn't stand a chance.
The story doesn't just end in the ancient past either. There is an incredible, dramatic conclusion that brings this deep-sea history right into the modern day.
Because the plume didn't vanish.
Right. That ancient mantle plume, that column of deep earth heat, didn't just flicker out and disappear. The researchers connected this ancient mantle quill to something people are very familiar with today. The data links this early phase of extreme heat directly to the current volcanic and geological activity that we see right now beneath the Azores.
It's the exact same system.
Yes. The islands of the Azores are essentially sitting over the modern-day continuation of that exact same hot material rising from the Earth's interior.
Which brings us to the sudden stop that preserved the whole structure.
Right. The trough didn't just keep growing.
No, the formation of the King's Trough didn't continue indefinitely. Eventually, the tectonic boundary that was ripping the weakened crust apart shifted its position. The boundaries separating the European and African plates moved southward, moving away from the King's Trough and aligning closer to where the Azores are today.
And because that tectonic boundary shifted, the violent fracturing process just stopped. The tension was relieved.
It just turned off.
Yeah, the tectonic plates moved their tug-of-war to a completely new location, leaving the 500-kilometer scar behind in the dark.
If we connect this to the bigger picture, the poetry of this event is truly remarkable. Geological processes rarely just stop and leave things perfectly intact.
Usually the Earth just paves over its own history.
Exactly. The Earth is a great recycler. It grinds away, overwrites, and destroys past evidence through constant shifting or subduction. You know, when one tectonic plate is just forced down under another and melts back into the mantle, the ocean floor is constantly being created and destroyed.
But not here.
Not here. Because the boundary shifted completely away from the trough, it left the King's Trough perfectly preserved. It remains one of the most impressive underwater formations in the entire Atlantic Ocean, precisely because the destructive forces moved on.
It's amazing.
What sits out there, 1,000 kilometers off the Iberian Peninsula, is essentially a frozen snapshot. It is a geological freeze frame of the Earth pulling itself apart millions of years ago, preserved in the silent depths of the ocean.
A 500-kilometer freeze frame. It is just breathtaking to think about a scar that massive sitting undisturbed in the deep.
It really is.
To wrap up our journey today, we started with a massive unexplained depression at the bottom of the ocean, a deep-sea mystery that completely defied the logic of surface erosion and confused geologists for decades.
And we've seen how this breakthrough study finally solved it.
By connecting a complex chain of ancient events, it took a deep mantle plume acting as a thermal blowtorch, a tectonic shift between Europe and Africa 30 million years ago, pulling at that weakened oceanic crust, and a sudden southward shift of those tectonic forces to leave the King's Trough complex perfectly preserved.
And the reason why all of this matters so deeply to our understanding of geology today is that it serves as the ultimate proof that our planet is a constantly living, shifting machine.
The ground beneath us is not static.
Not at all. By understanding these deep mental processes and ancient tectonic interactions, we are actively decoding the tectonic evolution of the Atlantic Ocean. And by extension, we are decoding the tectonic evolution of the very continents we live on. We are learning the exact mechanisms of how the Earth builds, stretches, and destroys its own surface over millions of years.
It is a phenomenal reminder of the sheer scale and power of the natural world. We get so caught up in our day-to-day lives on dry land, we forget that we are riding on top of a highly active geological engine.
This raises an important question, a thought to leave you with as we conclude today's deep dive.
So let's hear it.
If a massive 500-kilometer scar like the King's Trough was created by a shifting tectonic boundary that simply stopped, shifted south to the Azores, and left a perfectly preserved freeze frame of our planet's violent history behind, what other colossal, dormant scars are lying in the deep, unmapped ocean basins right now?
That is a fascinating thought.
How many other frozen snapshots of the Earth pulling itself apart are just waiting in the pitch black for us to finally send down a sonar probe and map them?
That is an incredible thought to mull over. It really makes you realize that the deep ocean is still holding on to so many massive secrets, just waiting for the right technology and the right researchers to uncover them. The map of our world is far from finished. We want to thank you for joining us on this custom deep dive today. We hope you found these insights as fascinating to explore as we did, and that you walk away with a whole new perspective on the unseen forces shaping our incredible planet. Until next time, keep exploring and keep wondering about the world beneath the waves.